Okay, so this is just me working through your problems. So if you get stuck, you can refer to this. But I really hope you've tried them before you're watching this video. Otherwise, you're not going to learn a whole lot just watching me work a problem. The first one is just the integral of cosecant 6x plus x. Now, we have a formula for just the integral of cosecant. It's one of our new horrible ones with natural log. But there's a 6x back here, so just to be on the safe side, I'm going to write down the u substitution and let u equal that 6 that's on the inside, that 6x, which means the derivative of u is 6. And now there's no extra 6 sitting out here, so we're going to take that 6 and move it to the other side as a 1/6, okay? And now that's actually great because when I go to rewrite this, then I'm going to be doing the integral, there'll be a 1/6, the integral of cosecant of u du. And I know I haven't done anything with that plus x, and it's just because it's a plus x, so I'm just going to do that integral separately. Okay, so just like this. So when you break this into the formula, you're going to end up getting, let me switch colors so you can see it. You're going to have the 1/6, and then the integral of cosecant is a negative natural log of cosecant plus cotangent. Now, I'm not just going to write cosecant x plus cotangent. I'm going to put that 6x back in there. Then I've got plus the integral of x, and then plus c. All right, and so that's how that one's going to turn out, okay? For the next one, it's a definite integral, so I'll be plugging in bounds when I'm finished, but first I need to sort of decipher what happens here. And a lot of times the denominator is a good choice for your u. Awesome, and then the derivative of the x squared plus 2 is going to be 2x dx. Now, that 2x does not match the 5x exactly, so I'm going to do basically the same thing I did on the last one. I'm going to bring the 2 over as a 1/2 on this side, and it's going to allow me to substitute for both of those, and my u gets to substitute that, and the 5 that's extra you can just bring out to the front. So that 5, since it's just a coefficient, I'm just going to bring it out in front of the integrand, and then that 1/2 I'm also going to bring out in front of the integrand. And so what will be left here is just a 1 over u du. And it's still a 1 here and a 3 here. Okay, so this is what I'm trying to reason through. Now the integral of 1 over u is just the natural log of u, and then I'll put my u back into the problem. So it's going to end up being 5/2 natural log of the u, which is x squared plus 2. And that is all from 3 to 1. So I'm going to do the fundamental theorem of calculus. I'm going to plug in the 3 first. And so that would be the natural log of 11. Okay? And then minus, I'm going to plug in the 1. So that'll be, I'm actually going to put this in parentheses and just leave the 5/2 out here one time. So if I plug in my 3, I get 11. If I plug in a 1, I get natural log of 3. Natural log of 3. There we go. And so you can write your answer like this. If you remember properties of logs, you can actually turn this into 5/2 natural log of 11/3. That's if some of you guys remember how to pull logs together. But either way, there's no calculator, so like this is it. This is my answer. Okay. All right. For the next one, it's a motion practice problem. It wants position given velocity. So to do that, you must integrate first. And the reason you have a point to deal with here is this is going to help you find the c that's in our equation. Okay. So, but first let's go back here and just integrate to get to position. So the integral of this would be t cubed over 3, and then there's already a 3 out front, so it's just going to be t cubed minus the antiderivative of 1 over t is just the natural log of t, and then I've got plus c. So this is my position p of t. This is my position equation. Now I'm going to take this information and actually find c. So the 1 is my t, and the 4 is my y, or my position. So 4 is equal to 1 cubed minus the natural log of 1 plus c. Natural log of 1 is 0. That's something we need to memorize. And then 1 cubed is just 1, so I'm going to move that over. So it looks like c is 3. And once I have that, I need to go, I'm not finished. I need to actually come back up here to where I wrote plus c, and then I need to put that 3 in. And that is my final answer. All right, just like that. So there's number 2. All right, number 3, I want you to find k given a definite integral. So if you don't freeze up, just start the problem like you know how to start the problem. You need to start by taking an integral. So the integral of 6x would be 6x squared over 2 and then minus 2x. And all of that is from 1 to k, or from k to 1. All of that is supposed to equal 5. So this is the math that you start with. I'm going to reduce that and make it a 3. There we go, just make it a little prettier. And then definite integrals mean the fundamental theorem of calculus. So let me plug in a 1, and I'm going to get 3 times 1 squared minus 2 times 1. Okay, so that's plugging in the 1. Minus, now I plug in the k. So it's 3 times k squared minus 2k. And all of that is equal to 5. 3 minus 2 is 1. And I've got a quadratic thing going on. So I'm actually going to move the 5 over here and try to get this thing set equal to 0 to see if I can solve it. So this is going to be a negative 3k squared plus a 2k. There's a 1 right here, and I'm subtracting a 5. So minus 4 equals 0. I highly doubt this is going to factor because I totally just made it up this morning off the top of my head. So probably not going to factor. And if it doesn't factor, then what needs to happen is the quadratic formula. So to find k, sorry, y'all are going to love me for this. To find k, we're going to do minus b plus or minus the square root of b squared minus 4 times a times c all over 2a. And we're going to clean that up. So let's see, 16 times 3 is 48, and it should be a negative 48. Did I really just create a problem that doesn't exist? Shame on me. Okay, guess what? No solution, because it looks like this is going to be negative, and we're going to go into imaginaries, and yeah, we don't want to do imaginaries. So there is no real value for k. Yay, sorry about that. Womp womp. So my next problem, number 4. Number 4, given the differential equation, find the particular solution that goes through the point 1, 0. So to find a particular solution, if you're given slope, you've got to work backwards, which of course means an integral or an antiderivative. This one may look bad, but if it's e, remember if you just choose your exponent as your u, these usually fall right into place. So u is x squared, so du is 2x dx. And that right there there's my x. That's what I needed. Looks like I was missing a dx here when I wrote the problem. Okay, so based on this, I'm going to rewrite this, and now it's going to be 1/2, because I need to move that 2 away, 1/2 e to the u du. And when I integrate that, it's just itself. So it'll be e to the, what was my u? X squared plus c equals y. So once we have this, we want to find our c. How do I know I want to find c? Well, because they gave me a point. So I can find c. So I'm going to plug my 1 in for x, my 0 in for y. Alright, and so basically that means that your c, if you rearrange, would just be negative 1/2 e. And I'm going to come back up to this equation that I wrote a second ago. I'm going to erase my c, and in the spot of c, I'm putting my negative 1/2 e. If you want to factor, factor. If you want to leave it alone, leave it alone. It's your choice. But that's how that one would play out. And for my last one, find the area under the curve y equals sine 2x between 0 and pi over 2. Well, area is an antiderivative, and it's telling you exactly what to bound yourself with, 0 to pi over 2. And so this is what I'm working out here. So if you do a little u substitution thingy on that, and then you take the integral, you're going to see that it turns into the cosine of 2x. Actually, it's going to turn into a negative cosine of 2x all over 2. And you're going to evaluate that between 0 and pi over 2. And then we're just plugging and chugging. Okay, plug and chug. We're going to put in the pi over 2 first. So we're going to be doing negative cosine of pi, all of that over 2, minus, we're going to plug in our 0, negative cosine of 0 over 2. Cosine of pi is negative 1, so negative negative 1, positive 1/2. Cosine of 0 is 1 minus a negative 1/2. And all that work for that pitiful little answer of 1. All right, come see me if you have any questions.